Okay, yes, so we have gone through the PowerPoint about your science experiment and how shadows are formed. So I'm just going to take you through an experiment. Now, I do have a couple of little helpers in school with me, so if you hear me calling the names, that's what that's about. So the first thing we need to do before we even set up our experiment is look at our prediction. So what we're trying to investigate is the size of the shadow depending on the distance the torch is, or the object is, from the torch. So I think that the shadow size will blank. Do you think it will increase? Will it decrease as the distance the object from the torch is? Does it increase? Does it decrease? You can word it differently if you want, but why do you think that? What do you know already about light that will help you to make that prediction? Okay, and once you've made that prediction and you are happy with what you are experimenting, you can go to your table of results, which is on the next desk. So you can see we have distance. Now, what are you measuring your distance in? Most of you will have rulers at home, in which case that would be centimetres, and you could pick 3 distances, more if you want to. Okay, and then look at the size of the shadow. Think about how are you going to measure that size of the shadow. Are you going to use a ruler and measure the width of the shadow? Or are you just going to use your rough guess, say which one was bigger? Are you going to just describe the shape? If you're using measurements, again, you need to put those measurements in those brackets there. Okay, so once you've done that and you've put your table together and you've done your experiment, we need something else. Come over here, glamorous assistants. We need our conclusion, okay? So we need to say what the results show. The results show that what increases, what decreases or increases. We need to say why. This is because, why do you think that is? What have you learnt? Okay, now the last table, if you like, of writing has got lots of scientific vocabulary that we have looked at, okay, so far in our light study. So we've looked at the word opaque. Think about what that meant. I did go through it on the science lesson earlier on the PowerPoint. We've got shadow, angle, reflect, absorb, light ray, reflection, refraction, remember they're not the same, filters, which we only looked at last week, coloured filters, transparent, translucent, and again we have those incident rays. Now, not all of this language will be used in this experiment, but you could use some of it, and which words are appropriate, that's the challenge. So we're going to go over to setting up the experiment now, and then I'll demonstrate it for you just a couple of times. I won't do the full experiment so it doesn't take away. So if we come over here, okay, so we can see I've set my torch up here and I'm just going to keep it flat for now, and that is going to stay the same. So that is our our dependent variable. It's the one that stays the same, okay? The dependent variable is the one that we measure. So we're measuring the distance. That's our dependent variable. Our independent variable is the one we're changing, okay? So we're changing where the coffee cup is. This torch has to stay the same. So at the minute, you can see I've got it on my meter stick and I've got it at 10 centimetres here, okay? So you could still do this with your ruler. So in a second, we'll turn the lights off. Just wait for the glamorous assistants. I will turn the torch on and we can see what happens to the shadow. Okay, so can we see the shadow there? We might have to come round this way or the other way, whichever way you can see a shadow. Can we lift it up? See if we can see that shadow. It seems to me like it's quite faint, maybe. You can just see a little bit perhaps here. So let's move it again, another 10 centimetres. Okay, so with 10 centimetres gap. And again, can you see what happens to that shadow? Okay, where is the shadow? Is it difficult to see? Okay, 30 centimetres. What happens? We tilt it up. It might be quite difficult to see, but it should be easier if you do this in your house. You should be able to see that. Another option is for you to test the angle of the torch. So if we move it back to our original place at 10 centimetres, It might be easier to see if you hold the torch in front. So one of my other glamorous assistants is going to come and hold this torch. And see, you need to make sure that the person who's holding that torch is the same. So you can see now you get a much better angle of the shadow. So that's at 10 centimeters. So you would make a note. Maybe you would measure the width from here to here. Okay, but make sure you're measuring the same width on each of them. So for example, when I move it, you still need to measure the widest part for that shadow. Okay, the torch is staying in the same place. My assistant has not moved their hand. The torch is staying in that same place. Okay, and then when I move 30 centimeters, what are you noticing? Is it getting harder to measure? Are you just going to have to look at your observations? 40. Okay, have a think. What's happening to that shadow? Okay, and then 50. Okay, and then let's look up to 60 centimeters. So you can see you can't really see that shadow. Why can't you really see it? What's happened? Where's it going? What does that suggest about the size? Okay, when we went back to 10 centimeters, the cup shadow fitted on our white desk here. When we go back up to 60 centimeters, the shadow doesn't seem to fit on the table anymore. Why might that be? What's happening? Okay, so if you can't do this experiment at home, you should be able to see the difference from this experiment that we've done in school. Okay, and I want to see it written up. If you want to do a slightly different version of the experiment, please do and send it in on Teams. We are looking for good work to put up on our wall. Well done, Year 6.